Hello, good day. So this is our first lecture video dito sa Basic Calculus. So bago nyo panoorin yung video na to, I suggest that you go back to the previous math lessons, in particular, yung mga algebra at trigonometry lessons nyo sa junior high school. So for this video, we are going to illustrate the idea of limits, the basic notion when we say limits to understand kung paano natin ito ginagamit dito sa basic calculus. So let's start. So when we say limits, the very idea of limits, it deals with the behavior of a function as it approaches a certain point. So kung mapapansin nyo, naka-bold yung behavior of a function. So pag sinabing behavior, yung nangyayari doon sa paligid ng point of interest mo. So, halimbawa, let's have an example. We have the function f of x. F of x is equal to x squared. And let's say x approaches 2. Alam natin na yung function na to, yung value niya ay 4 when we let x is equal to 2. Pero pag sinabi nating limits, we are concerned what happens when we approach 2. So, ang pinaka-idea kasi, pag sinabing the value of a function, so sa case na to, we have f of x is equal to x squared. Kapag sinabi nating f of 2, which is when x is equal to 2, that is equal to 4. And that is what's happening exactly at that point. Pero pag sinabi nating limits, we are concerned what's happening around that point. So, sa case na to 2. So, how can we know that? Let's have this table of values. So, dun sa x, okay? So, for example, this is the number line. So, ito yung 2. Dahil concerned ka dun sa nangyayari around that specific point, so you will let values or you will let x have values very close to 2. Okay? Very close but not equal to 2. So, mula dun sa left side, papalapitin mo sa 2. Tapos mula dun sa right side, papalapitin mo sa 2. So, dun sa first table, ganun yung ginawa natin. So, nag-start tayo sa 1.99 and then we go on near 2 but not equal to 2. So, 1.999, 1.9999, and so on. Nung pinlog in natin si x dun sa f of x, ano yung naging result? So, that's 3.9601, 3.996001, and so on. Tingnan natin yung behavior. Saan siya lumalapit habang mas lumalapit ka sa 2. Ayan. And then, ganun din, dun sa right side, papunta sa 2. So, let's have 2.01. Then, mas paliitin natin 2.001, 2.0001, and so on. Ngayon, habang mas pinapalapit natin sa 2, mas pinapaliit natin yung value, saan lumalapit yung f of x? So, pag pinlog in mo yan dun sa f of x, nagiging 4.0401, 4.004001, lumalapit siya saan? So, lahat, yung both cases na to, obviously, lumalapit siya sa 4. Dahil yung behavior niya, habang lumalapit sa 2, ay lumalapit sa 4, what can we say? So, as the value of f of x approaches 2, from the left or from the right, the value of f of x gets closer and closer to 4. Because of this, we can say that the value 4 is the limit of the function as x approaches 2. It can be written as lim f of x as x approaches 2 is equal to 4. Or pwedeng instead of f of x, yung mismong function na yung ilagay mo. So, yung lim, and then followed by the function, and then dun sa baba ng lim, kung saan value mo siya pinapa-approach. And then, you have the equal sign, and then kung ano yung limit. Now, how can we analyze that graphically? So, kung titingnan natin yung graph, so eto yung graph ng f of x. So, this is a parabola, x squared. So, ito yung mismong graph. yung parabola na yan. Ngayon, etong value nung x, so ito yung 2, habang pinapalapit mo siya, you are concerned, anong nangyayari dito? Okay? So, habang pinapalapit mo siya, yung f of x mo, papalapit din ng papalapit dito. Okay? Mula naman sa right side, papalapit din siya ng papalapit. Kaya, we can say that the limit of f of x is equal to 4. How can we generalize the idea of limits? How can we generalize? So, let's say na we have a real number c. So, consider c as an element of R. Huwag kayong matakot dito sa side na to. Ibig sabihin lang nito, element. Ibig sabihin lang nung R real number. So, ang sinasabi lang niyan, yung c ay isang real number. And then we have L is also a real number. So, let's say we have f of x, be a function of x, defined on an open interval containing c, except possibly at c. So, let's say meron tayong function, yung given natin dun sa example 1 is x squared. So, it is defined on an open interval containing c. So, kindly just verify na itong x squared, define siya sa open interval na negative infinity tsaka positive infinity. Okay? Now, yung c, so this is some point inside that interval. Ngayon, if f of x approaches L, again, L is a real number. That's just the real number. So, if x approaches L as x approaches c, then L is the limit of f as x approaches c. Ayan. So, it can be written as the limit of f of x as x approaches c is equal to L. So, yan yung pinaka-general idea ng limits. Ngayon, kailangan nating tandaan yung dalawang bagay na to. First, the limit may or may not exist. So, pwedeng merong limit, pwedeng wala. And then, if the limit exists, it must be a single number. So, let's have more examples. Let's have this one. Consider f of x is equal to x plus 1 as x approaches 3. The value of the function when x is equals 3 is 4. So, f of 3 is equal to 3 plus 1 is equal to 4. Okay? This is equal to 4. Now, again, hindi mo concern kung ano yung nangyayari at that point. You're not concerned what happens at that exact point. You are concerned what happens as you approach that specific point. So again, mag-table of values ulit tayo. Tingnan natin kung anong nangyayari. So, ito yung number line. Okay? Ito yung 3. So, habang pinapalapit mo siya from the left side, so ito yon 2.99, 2.999, and so on. Yung values ng f of x, kung titingnan nyo yung trend, that's 3.99, 3.999, and so on. Kapag naman from the right side, pinapalapit nyo siya sa 3, so 3.01, 3.001, and so on, mapapansin nyo din na yung value ng f of x ay nag-a-approach sa 4. So from this idea, tingnan natin yung graph. So kung mapapansin nyo, ito ulit yung graph, itong straight line na yan. By the way, yung green lines, guide lang natin yan para matukoy natin yung part na may limit. Pero itong line, kung mapapansin mo, habang lumalapit ka dito sa 3, yung x values, anong nangyayari dito sa graph? Papalapit din siya sa 4. And then from the right side, going to the left side, papalapit din siya sa 4. Hence, from this notion, we can say that the limit of f of x as x approaches 3 is equal to positive 4. So, another example, consider f of x is equal to x squared plus 1 as x approaches 2. The value of the function when x is equal to 2 is 5. So, f of 2 is equal to 2 squared plus 1. Sige, ulitin natin yung... Okay. So, let's rewrite. This is f of 2 as x approaches, f of 2 is equal to 2 squared plus 1. So that's just 5. Ngayon, yan yung value ng function sa 2. Again, pag limits, behavior lang. So what happens around that point? Let's consider the table of values. Ayan. So, let's start on the left side. So yan, ito yung 2. So ito yung 1, para lang din mas malinaw. Habang lumalapit ka sa 2, so that's 1.99, 1.9999, and so on. The value of f of x, kung titingnan nyo yung trend, 4.9601 hanggang nakarating sa 4.999, it's approaching 5. Ngayon, kapag naman from the right side going to the left side, pina-approach mo sa 2, so 2.01, 2.001, and so on, itong value ng f of x, papalapit din siya ng papalapit sa 5. Okay? So, obviously, from this table of values, alam na natin yung limit. Pero tingnan din natin sa graph. Kung makikita nyo dito sa graph, ayan, ito yung parabola, itong pa-letter U na yan. Ano ba yung nangyayari kapag pinapalapit mo sa 2? Dito ako nagmamark sa x-axis kasi values ng x to. So, para lang din clear. So, habang pinapalapit mo sa 2, yung x, anong nangyayari dito? Saan din siya lumalapit? Dito sa may 5. Okay? Ito, tong right side, habang pinapalapit mo sa 2, sa 2 din, sa 5 din siya lumalapit. Okay? So, para lang din malinaw, ito kasi yung x, ito yung y-axis, which is also f of x. Kaya habang lumalapit dito sa 2, saan siya lumalapit dito sa y-axis? Dito sa 5. So, from this, we can say na as the value of x approaches 2, from the left or from the right, the value of f of x gets closer and closer to 5. Hence, the limit of f of x as x approaches 2 is equal to 5. Okay, so yun yung mga basic examples nung behavior nung function around that specific point. And so, dun sa mga napag-usapan natin, kung mapapansin nyo, yung f evaluated at some point, ayan, hindi naman yun yung concern natin eh. Yung concern natin, what happens around that point. Pero dun sa mga example, kung mapapansin nyo, yung f evaluated at that point, parang equal lang din naman siya sa limit. So does that mean f of x evaluated at a number is equal to the limit approaching that number? So, ibig sabihin ba na, halimbawa, meron kang a number c, x is equal to c. So, when we say f of c, okay, let's say equal siya sa L. So, ibig sabihin ba na yung limit nung f of x as x approaches to c equal din sa L? Lagi bang true yan? So, kanina dun sa example natin, we have f of x is equal to x squared, and then x is equal to 2. Ngayon, alam natin na yung f of 2 is equal to 2 squared, which is equal to 4. Ngayon, ibig sabihin ba niya na yung limit ng f of x as x approaches 2 is equal to 4? Well, dun sa nakita natin, yes. Pero ang tanong, lagi bang ganyan? Lagi bang equal yung limit dun sa evaluation nung function at that point? Lagi bang ganon? So, the answer is, it can happen, but not all the time. So, kumuha tayo ng example na hindi yun nangyayari. So, we have this example 4. So, observe f of x is equal to x squared minus 4 over x minus 2. Kapag nag-substitute ka ng x is equals to 2, so f of 2 is equal to 2 squared minus 4 over 2 minus 2, ang makukuha mo ay 0 over 0, which is not equal to 0. Okay? This is an indeterminate form na later on madidiscuss natin. Pero in some other terms, hindi defined yung function dun sa x is equal to 2. Ibig sabihin ba nun, hindi na nag-exist yung limit? Hindi. Kasi, we have to observe the behavior of f of x when x is very close to 2. Ayan. So, gagamit ulit tayo ng table of values. Pero dito medyo naka-vertical version na. Sorry, horizontal. Ayan. So, ito yung 2, habang pinapalapit mo yung value sa 2, mula dun sa left papunta sa right, so 1.9, 1.99, pag pinlog in mo yun dun sa function, ang makakuha mo ay 3.9, 3.99, 3.999, and so on. Kapag naman from the right side going to the left side, kapag pinlog in mo yung function, 2.1, 2.01, paliitin mo pa ng paliitin papunta sa 2, ito yung nagiging values. From 4.1, naging 4.01, 4.001, and so on. Anong napansin nyo? Ayan. Pero by the way, hindi siya defined dito sa 2, so wala kang ilalagay dyan. Undefined dyan. Pero anong napansin nyo habang pinapa-approach nyo sa 2 on both sides? Saan siya nag-approach? Di ba sa 4? Okay. So, ibig sabihin, yung limit nung function x squared minus 4 over x minus 2 as x approaches 2, that is equal to 4. Again, hindi ka concerned sa nangyayari at that point, you're concerned about that behavior. Ayan. So, kung titignan mo yung graph, ano bang itsura nung merong undefined na part? So, yung undefined na part, isa siyang hole. Meron kang hole doon sa graph. Meron kang hole dyan. So, hindi yan kasama sa graph. Pero bagaman meron kang butas dyan, concern ka lang naman sa nangyayari around that point. Yun lang yung gusto mong mahanap. Kasi yun lang naman yung dire-describe ng limit. So, habang pinapalapit mo sa to yung x values, lumalapit yung function sa 4. From left and from the right. So, dito natin makikita na hindi porket undefined siya dun sa specific point, hindi siya defined dun sa specific point, hindi ibig sabihin na wala na agad limit. Okay? You have to observe the behavior around that point. Okay. So, hence, the limit of f of x as x approaches a point C is not necessarily equal to f of c. So, sa case ng example na to, yung f of c mo, f of 2, undefined, or indeterminate. So, pero yung limit mo, meron ka pa rin nakuha. Ayan. And another point that we need to remember, kapag naghahanap tayo ng limits, we let x approach both sides of c. Yun naman din yung ginagawa natin kanina. Ngayon, merong mga cases na ganito. Meron tayong piecewise function here. Particularly, we have a heaviside function. So, we have f of x is equal to 2 minus x when x is less than or equal to 2, but equal to 3 when x is greater than 2. Ngayon, kapag tiningnan mo yung graph niya, meron silang putol, magkahiwalay yung left tsaka right side niya. And ano yung limit ng f of x as x approaches 2? Hindi mo pwedeng sabihin na limit of f of x as x approaches 2 is equal to 0. Hindi mo pwedeng sabihin na is equal to 3. Bakit? Although, kapag pina-approach mo dito sa left side, pag pina-approach mo sa left side yung function, itong function, bumababa siya, di ba? Ano yung nagiging y value? 0. Pero pag sa right, pinapunta mo sa left, ano yung nagiging y value? 3. So, magkaiba yung left tsaka right side. Pagka ganitong case na magkaiba yung left tsaka right side, what can we infer? Ibig sabihin, the limit of f of x as x approaches 2 does not exist. Kasi, sa limits, dapat both sides yung concern. Sa left tsaka sa right. Okay? Pero pag hindi sila equal, you cannot say na it has a limit. The limit does not exist. So, what should we remember from this? First, limits deal with the behavior of a function as it approaches a certain point. So, concerned ka sa nangyayari around that point, but not exactly at that point. In finding limits, yung limit of f of x as x approaches c is not necessarily equal to f of c. Hindi laging equal yung limit sa evaluation ng function at that point. And to find the limit, we let x approach both sides of c. Ngayon, dito sa video na to, diniscuss lang natin yung intuitive notion ng limit. Pero, how do we evaluate limits directly? This would be the subject of the next lecture video, which will discuss about limit laws. So, before this video ends, don't forget to like and subscribe to this channel. Bye!